Today we will discuss about microsystem for microrobotics. As far as these microsystems are concerned, so we have multiple subsystems which are available. So, these subsystems can be integrated to take care of the required functional applications. So, like for example, if I need to develop a kind of a small micro robotic system for endoscopy related applications, etc. So, appropriately I may need to integrate certain sub elements like micropumps, micro actuators. We can integrate these systems and appropriately we can deploy it for a functional related applications. So, in this aspect, like in this particular module, so we will discuss about the different microsystems which are available for micro robotic related applications. We will also discuss some of the key case studies which are being deployed for these particular applications. Now, for a better understanding, I have divided these modules of these micro system for micro robotic applications under 3 different categories. One category is towards actuation, the other category is towards manipulation, and the third category is towards integration. So, with reference to actuation perspective point of view, this module 5 for this week we will be focusing on the microsystem related to actuation. So, under this actuation perspective point of view, we will be discussing about micropumps, micro engines, and we will also be discussing about the different configurations of micropumps and micro engines, different actuation systems which are being deployed for micropumps and micro engines, different case studies and applications relevant to micropumps and micro engines, and then we will also discuss about one of a peculiar aspect which is called as magnetic helical micro machines, which we will discuss in detail with reference to the relevant case studies. Now, first we will discuss about micropumps. So, micropumps is considered to be one of the key element in the case of microsystem for micro robotic application. So, as far as pumps are concerned, we are well aware about it. These pumps are efficiently used for discharging. For micro robotic perspective point of view, these micro pumps are efficiently used for discharging certain amount of targeted drug delivery or to reach a particular point and to have a control over the flow rate, etc. So, these are some of the applications. Of course, we will go in detail into different applications relevant to micro pumps. So, with reference to micropump perspective point of view, so we have the inlet reservoirs. So, this is the overall configuration of a micropump. So, in the case of a micropump, so we have an inlet reservoir in place, then there is a flow sensor in place, and then there is an outlet reservoir in place. So, the micropump needs to be appropriately actuated. So, it is fed by an appropriate actuated signal, and then the reservoir which is available either in the case of a targeted drug delivery, the concerned drug will act as a reservoir. From the reservoir, the drugs are being pumped and it is being fed into the system. Then there is a controller in place. So, the main function of the controller is to control the micropump for an appropriate actuation. Then we have a flow sensor in place. From the flow sensor, we are moving it to the outlet reservoir. So, in order to appropriately have a control over the flow, so here the flow sensor, the signal conditioning system and the controller will be efficiently participating in it, so that we can optimally use these micropump for the relevant application or for the relevant functionality. So, here in this particular case, this inlet reservoir and outlet reservoir play a vital role. So, the overall configuration of this inlet reservoir and the outlet reservoir highly depends upon the overall type of the fluid what we are using, the overall functionality of the fluid or the system what we are going to work upon. Okay. Now, let us discuss about the overall overall history of these micropumps which are being developed. These micropumps were initially developed in 1978. So, the first piezoelectric actuated micro machine micropump came into existence by W.J. Spencer. So, where the first active valves based micropumps were integrated. Then in 1979, the first solenoid actuated micropumps were developed. Slowly, with the invention of piezoelectric with reference to an appropriate modification in piezoelectric structures, the first piezoelectric actuated micropump with passive valves was established by Van. Then later in 1990s, the first thermo-pneumatically actuated micropump came into existence. Then slowly with the increase in the technology related to electrostatic related actuations, the first electrostatically actuated micropump was realized in 1991, and in 1993 the first valveless piezoelectric based micropump were realized. Okay. So, with reference to valveless based micropump, it has a good efficiency. So, we will discuss in detail about this valveless micropump. So, based on this, we could understand like actuating behavior play a vital role in categorizing the micropump for our different requirement or the different characteristics. That is how the first ICPF actuated micropump came into existence, and in 1997 shape memory alloy based micropumps also started getting realized with the overall architecture for different applications and for relevant structures. So, ideally with reference to biomedical perspective point of view, piezo and shape memory alloy based micropumps are effectively used. As far as shape memory alloy based micropumps are concerned, in most of the cases either it is shape memory alloy polymers are used or shape memory alloy based thin films are used. So, where it is highly biocompatible and appropriately it is being efficiently used for some of the targeted drug delivery like insulin injections etc., are some of the key applications of this micropump. Now, if we closely observe the overall application of the micropump with reference to the different technological advancement. So, these micropumps are efficiently used for dosing system, microelectronic cooling, space exploration, it is used for fuel cell related application, biological analysis, and then it is also meant for a targeted drug delivery. So, in fact, as far as this targeted drug delivery is concerned, so these micropumps are being efficiently used since 1975. Similarly, like as far as dosing is concerned, which includes insulin dosing, which also include a targeted drug delivery dosing etc. So, for those applications also such kind of micropumps are efficiently used. Then later, so we had some interaction with reference to chemical and biological analysis, with reference to space exploration, microelectronics related application, especially for microelectronics cooling, and then fuel cell related applications has been efficiently established by these for the application of this micropumps. Now, when we try to classify these micropumps, so these micropumps are classified into two. So, one is called as a mechanical type micropump and the other one is called as a non-mechanical type micropump. Again, in the case of a mechanical type micropump is concerned, we can classify this mechanical type micropump into two. One is called as a reciprocating type micropump and the other one is the rotary type micropump. So, a rotary type micropump, ideally we all know centrifugal based pumps are being deployed for different applications. As far as reciprocating pump perspective point of view, so we have a diaphragm and a piston arrangement which is being efficiently deployed for different applications. In the case of a diaphragm based micropumps, based on the actuation medium, we can classify these diaphragm based micropump. So, like if I try to classify this diaphragm based micropump, so we have the driver base, the chamber base and the valveless base. So, in the case of a driver base, we have a piezoelectric structure based system, the electrostatic structure based system, the electromagnetic based system, thermo-pneumatic based system, a shape memory alloy based system and the phase change material based systems are some of the key drivers which are being deployed for developing diaphragm based micropumps. As far as chambers are concerned, so we have a multi-chamber micropumps which are being established, a single chamber micropump which has been established. So, in the case of a multi-chamber micropump, again we can classify this multi-chamber micropump into two. One is called as a peristaltic based micropump and the other one is called as a parallel based micropump. Now, when we try to classify these kind of actuators, these kind of micropumps with reference to valves perspective point of view. So, we have the active and passive valves, that is by effectively having an efficient control system, appropriately we can have the active based valves and the passive based valves. Then there is a flap valve based valves which are available under the micropump category, then a ball valve based micropumps, Tesla valve based micropumps, a valveless micropumps, nozzle and diffuser micropumps. Now, when we try to look into the classification of non-mechanical based micropumps, we have the electro-hydrodynamic based micropumps. We will be discussing about it. So, we also have the magneto-hydrodynamic based micropumps, electro-osmotic based micropumps, electrochemical based micropumps, acoustic, streaming or ultrasonic based micropumps are also being deployed for different functional applications. Ideally, among these particular classifications, the selection of micropump is basically decided by the appropriate actuation by the availability of appropriate actuation mechanism, as well as by the appropriate usage or by the appropriate applications. We can select the micropumps based on our requirement. Now, let us see some of the key fundamentals and the sub elements which are available for the development of this micropump. So, under this micropump, one of the key aspects include this micropump material. Then we have the different fabrication process or the fabrication methodologies which are being deployed for this micropump development. Then we have different diaphragm design and material which are available. So, there are different chamber configurations are there which basically exhibits on this micropump. So, we have a micropump based valves and the micropump based drivers. So, as far as these micropump materials are concerned, so we stainless steel, silicon and mild steel plays a vital role. There is a brass, silicon, glass, aluminum steels are available, and then we also have a SI, glass, parallel, aluminum and PDMS and PMMA structures also efficiently contribute towards this micropump related materials. Now, with reference to like if I try to look into the overall aspects of these micropump related materials, I can categorize into two. One is a kind of a static based material which is used for an appropriate insulation or appropriate protection, or a dynamic based material where it is used for an appropriate actuation for relevant applications. Okay. So, the material what we had discussed now is mostly works on the static based systems, whereas on a dynamic based systems automatically the diaphragm design and the diaphragm material comes into the picture. So, these materials are deployed for appropriately maintaining the overall geometric configuration or appropriate insulation to protect the different interference which exhibits over there. Now, let us discuss about the different fabrication process which are being deployed for this micropumps. So, in this perspective point of view, so like as far as a micropump configuration is concerned, so we may need to have both the top down approach and the bottom up approach. So, conventional machinings can be deployed, micro etching can be deployed, surface micro machinings can be deployed. In addition to this, like micro etching, micro machining, injection based micro molding, stereolithography, etc. are some of the fabrication process. In addition to this, like if I try to map it with reference to the material, so wherever I have a kind of a highly sophisticated material, like a highly sophisticated material which has a direct relevance towards microsystem related applications, then I may need to go for a specialized techniques like deep reactive ion etching, a printed circuit board technology, a plastic molding or spin coating, etc. However, in certain cases where I need to go for an appropriate operation, then I may need to go for a CNC machining, a casting and molding, a spin coating technique for taking care of the thin film coating, etching, deep reactive ion etching and the electroforming process are being efficiently deployed. Now, let us discuss about the diaphragm material which are being used for this micropump related applications. So, as far as in this diaphragm materials are concerned, we have a flat stainless steel polyurethane foam with glass which is available, and then we can also have a kind of a diaphragm like a kind of a corrugated diaphragm, or we can also have a PDMS based diaphragm. In certain cases we can also have a metallized Kapton based diaphragms which can be deployed. Now, in addition to this, there are certain elements which has a direct relevance towards diaphragm like PDMS, rubber, elastomers, latex levers, etc. can be efficiently deployed for diaphragm related applications. Now, let us discuss about the chamber configuration. As far as this chamber configuration perspective point of view, we have a single chamber which is a kind of a circular section, and then we have a single chamber with series configurations which includes a peristaltic chamber and a series parallel chamber configurations. And we can also design a chamber which is a kind of a single disposable chamber, a kind of a 4-stage peristaltic chamber, and then we can also discuss about the single with circular and a rectangular chamber. And there are some chambers with kind of rib kind of structures are also being deployed with peristaltic chamber related applications. Now, let us discuss about the different configurations of micropump or the different orientations and configurations of micropump. So, when I try to classify this micropump with reference to valves perspective point of view, we have an active flap valve, that is a piezo actuated passive structures which are being deployed. So, there is a kind of a passive diaphragm type cantilever valves and valveless systems are being deployed. In certain cases, there is a nozzle or a diffuser or a passive diaphragm valve with flexural hinge and valveless Y-shaped pipes are being deployed. Next, in addition to this, so there are some nozzle diffusers are there, active flap cantilevers are there, a valve magnetic, a shape memory alloy valve based actuation systems are being efficiently used for such kind of valve or valveless micropump. Then we can also discuss about the micropump drivers. So, as far as this micropump driver perspective point of view, there are different types of micropump drivers which are being efficiently contributing towards the configuration of this micropump. One such driver includes the piezoelectric disc or the solenoid, and then we also have a piezoelectric disc, a thermopneumatic structures, electrostatic structures, ionic conductive systems, polymer films and the shape memory alloys. With reference to highly sophisticated systems, so we have an electromagnetic based structures, a piezoelectric based structures, solenoid based structures and the shape memory alloy based structures are also efficiently contributing towards development of such kind of structures. Then as and when there is an improvement in the microfabrication, appropriately we can develop these drivers or we can customize these drivers based on our requirement. So, one such includes a piezoelectric, that is a disc plate stack based system with electromagnet and ionic conductive polymer film, a magnetic shape memory alloy and a solenoid based electrostatic structures can also be deployed appropriately. Now, let us discuss about the overall configuration of a micropump. So, as far as micropumps are concerned, as we had discussed earlier, these micropumps are designed to transport fluid in a controlled manner with the micro scale. So, when we try to look into the overall configuration of it, so in this configuration, so there is a piezoelectric sheet is there and then there is a diaphragm arrangement which is available. There are two valves are there. So, this is a kind of an inlet valve and this is a kind of an outlet valve. So, and here we have the inlet reservoir in place and here we will be having a outlet reservoir in place. So, what happens is the liquid from the inlet reservoir is pumped and through the valve it is made to pass through the valve. The suction is happening through the diaphragm and the actuation of the diaphragm is taken care by the piezoelectric sheet which is available over here. So, the main application of this piezoelectric sheet is to create a kind of a suction mechanism, so that the diaphragm will move along with the piezoelectric actuator and it creates a suction in this domain, finally leading to pumping the liquid from the reservoir and the liquid is made to flow through the outlet. So, here we are trying to classify or we are trying to look into this fundamentally into two modes of operation. The first mode of operation is called as an absorbing mode. So, in the case of an absorbing mode, the absorption happens because of the movement of the diaphragm and because of the suction of the liquid, and the liquid is being made to flow through the outlet valve in an appropriate process. Next, in the case of a dispensing mode perspective point of view, the diaphragm is made to push in the downward stroke. When the diaphragm moves appropriately, the liquid is made to pump or the liquid is made to push towards the walls and then it tries to move out of it, it tries to flow out of the wall. So, ideally, like in the case of an absorbing mode, the piezoelectric structures will be in a particular actuation state. so that it will initiate a kind of a suction mechanism, and then in the case of a dispensing mode, appropriately the piezoelectric sheet is pushed towards in the forward stroke, so that a pressure is created, the suction mode is being stopped, the suction mode is stopped and a pressure is created and the fluid is made to flow through the surface. Now, like basically if you try to look into the overall functionality perspective point of view, or when we try to quantify the parameters perspective point of view, so we may need to look into the frequency of this pump as well as the overall actuation displacement of this pump. So, in that aspect the operating dimension will range from few micrometers to several millimeters. It enables a precise fluid handling for various applications. So, this precise handling will be in the form of like kind of either it can disperse in few microliters with a particular frequency based on the application. This is in the case of a passive type. So, in the case of an active based micropump, what happens is we try to take a feedback like so in the basic configuration we have seen, there is a sensor which is available. That sensor will get the overall output from the output reservoir, and from that it will try to give an appropriate signal to the actuation condition, so that the pumping happens and the pumping is appropriately used for dispensing the fluid. Okay, like for example, in the case of an insulin processing. So, what happens is like after a particular time interval, automatic dispersion happens. So, automatic suction absorbing, so automatic absorbing mode and dispensing mode happens because of either with a timer or sometime with reference to the requirement from the output, appropriately the absorbing mode or the dispersing modes gets activated. So, the use of this motion of a solid such as gear or a diaphragm or a fluid generate the pressure difference which is needed to move the liquid. So, ideally these gears and or diaphragm act as a main key actuating medium for the movement of the fluid. So, the most common mechanical displacement micropumps are the diaphragm pumps. So, like when we try to talk about the diaphragm pumps, we have wide varieties of diaphragm pumps, either it might be a shape memory alloy based or it might be a piezoelectric based structures. Then in the case of a mechanical micropump, so it utilizes a kind of a diaphragm actuated by a physical actuator for pumping the fluid that leads to a pressure drop. So, this pressure drop causes the fluid to flow from high pressure reservoir to the pumping chamber, which corresponds to the supply mode. So, ideally like as discussed earlier, the working principle involves the volume change in the pump chamber by the diaphragm as well as by the mechanical element, and these are some of the basic configurations where we will be having two modes. One is a kind of an absorbing mode and the dispensing mode which exhibits. Now, let us discuss about the configuration. One of the key configuration of micropump is a kind of a valveless micropump and a valve micropump. So, in the case of a valves micropump, so during the expansion phase the chamber volume increases and it creating a negative pressure that draws the fluid in through the liquid, and during the compression phase the chamber volume decreases and create a positive pressure that forces the liquid to flow through it. Now, if you closely observe the overall illustration of this valve and valveless pump, this is how exactly the valve and the valveless pump phase. In the case of valve in the valve pump, so there will be a valve which will be there to restrict the overall flow, and it will also be helpful to hold the pressure and appropriately push the go for a kind of a dispensing mode. So, the valve will take care of the absorption mode, will participate in both absorption mode and the dispensing mode appropriately for the appropriate fluid out. So, now in this particular case, so like if you closely observe, there are two modes are there. So, one is called as a supply mode, which is nothing but the absorption mode through which the fluid is pushed. The valve also act upon, and as I had mentioned earlier, valve also participate with the fluid in, and the liquid will try to fill through this structure, and then there is a pump mode which is available. So, during this pump mode, in some cases the diaphragm tries to push, in some cases it is because of certain other actuation principles, and then there is an outlet which is coming out of it. Okay. That is a pump mode. Through the pump mode the fluid is made to pressurize towards the outlet unit. Now, in the case of valveless perspective point of view, so this is a kind of a valveless configuration which exhibits. So, in this valveless configuration if you see, so it is a kind of a kind of a process in which like there is an efficient flow is taken care. So, in these valveless micropumps are efficiently used for certain amount of passive based system. So, in this passive based systems, so what happens is like based on the output or based on the overall environment, appropriately the passive base will react, and then it will try to appropriately the active base will react and it will try to disperse. So, in the case of a valves, so we can use it for both active and passive. In the case of a valveless also we can use it for both active and passive, and the valveless is efficiently used for a certain amount of active base systems, like based on the change in the environment. So, appropriately we can disperse the liquid. Okay. So, now let us see some of the key application of these pumps. So, this is a kind of a overall idealized configuration of a pump. So, one is with reference to absorbing mode and the dispensing mode, other one is with reference to valve and with reference to valveless. So, with reference to application perspective point of view, like the first application is towards targeted drug delivery for biomedical related applications. So, like it can reach a particular point and then we can disperse a kind of a drug for a immediate relief. Then we have a thermal management for electronic cooling. So, that is, so we wherever there is a kind of an electronic system which is available. So, in order to take care of the thermal management, such kind of systems can be deployed. Then there is a gas chromatography system. So, in this gas chromatography system, so basically a mixing of gas happens, so that appropriately we can have a control over the convection behavior of this system. Then we have the kind of a fuel cell where the delivery of fuel in combustion, and the fuel cell exhibits in such a way that like wherever there is going to be a combustion, appropriate relief of the fuel is being taken care by this system. Okay. Like I can give you one of an application where a kind of pump can be deployed for dispensing the lubrication in a kind of a controlled environment. Like suppose we have a kind of a roller bearing or a kind of a bearing which is being employed for certain applications. So, where in the controlled environment it is very difficult to pump the lubricant on those particular rollers or bearings, etc. So, in those conditions there is a requirement of such kind of micro pumps which will be deployed appropriately, and these micro pumps will try to dispense the fluid on these rollers, and then like based on the variation in the pressure difference, appropriately it will try to dispense the liquid on the roller bearing, and we get a kind of an efficient process coming out of it. So, in those conditions those are kind of an active based system, either it might be a valve or valveless based on the configuration. However, here when we try to look into the output perspective point of view, either it might be because of the overall suction behavior which exhibits, or sometime it might be because of the thermal management also. That is, in such kind of bearings, when there is a kind of a heat which is getting generated, that can also be sensed, and appropriately a kind of a liquid can be dispensed on those particular or the liquid can be lubricated appropriately for a reduction in the temperature, and which can be efficiently used for a kind of an efficient lubrication system. So, ideally these micro pump can act as a kind of an efficient lubrication system over here. So, in the upcoming classes we will be discussing about the different configurations of micro pumps. So, we will also be discussing about this like different actuation mediums which are being deployed for the micro pump related applications. So, we will also take one case study where micro pumps has been used for an endoscopic related application. So, we will go through one of the key configurations where there is a kind of a micro motors are being integrated into it, and how it is being used for an endoscopic application for a targeted drug delivery.